So our goal today is just to kind of review what we saw in grade 9 with the equations of the line. Last year we saw that there were three different types of an equation of a line. So we want to be able to, we'll just redefine those, the three forms. And then we want to determine the equation of a line. So we'll be given some information and we'll be asked what the equation of that line is. Okay, so to determine the equation of a line, there's two things that we need to know. One is we need to know a point on the line. So we always need to know at least one point. And if we think about that, if this is my coordinate system, here's a point. Well, I mean, that could be a line, 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 assuming they're all going through that point. So we also need to know what the slope of the line is. With those two pieces of information, we can describe any line with an equation. And what we saw is that there are three possible, or three kind of standard forms for an equation of a line. One is the point slope form. And that we want to use that if we have if we're given that point and we're given a slope. And that was derived last year from the slope of a line, which is the equation becomes y equals y minus y1 being the point that we're given, is equal to the slope m times x minus x1, where x1 is on the point that we're given. So this is the equation of a line that we would use if we were given our slope and if we were given a point x1, y1. So that x1, y1 needs to be a point on the line, and n is the slope of that line. Okay, so that's known as the point slope form, and that's the standard form of an equation that we just need to memorize. Standard form is where we have our coefficients a, b, and c, and that becomes ax plus by plus c equals 0. That's known as standard form. And remember that there's a special condition that a, b, and c cannot be fractions. So we say a, b, and c belong to the integer values, and that a and b are not both 0. So if a and b are both 0, then that doesn't actually become a line. And we add one extra condition, which is helpful for next year, and we say that a must be greater than or equal to 0. So we cannot have a negative value for a. Okay, that's known as the standard form. Again, another form that we simply need to remember, to memorize. And then finally, our slope y-intercept form. This is probably the one we use most at the moment, and that's just where we say y equals mx plus b, where m is the slope, m is the slope of the line, and b represents the y-intercept. All right, so those are the three standard forms. And so if I were to ask you what is the point slope form, you should be able to recognize and write down the general equation of the line. And if I asked you the equation of a line in standard form, you should be able to write it in the form ax plus by plus c, or the third form, slope y-intercept form. Hopefully at this point in the course, you've used these equations enough that they're very familiar with you. So here we've got some examples where we're going to be asking to find the equation of a line. So in this case, we're given, or we're asked to find the slope and the y-intercept given our equation 2x plus 3y minus 6 equals 0. So I recognize this as being in standard form. So there's two ways that we could do that. We could rewrite this, rewrite the equation. Oops. Rewrite in slope y-intercept form. Right, so we just need to rearrange our equation in the form y equals mx plus b. So I could do that by leaving the 3y on the left-hand side. I'm going to subtract my 2x from both sides, minus 2x. So if I subtract 2x from the left-hand side, that disappears, but I also need to then subtract 2x on the right-hand side, giving me minus 2x. 3y is also attached to minus 6, so I want to get rid of that by adding 6 to both sides. If I add 6 to the left-hand side, that goes to 0, but I must then add 6 on the right-hand side. So I add 6 there. And now I need to divide both sides by 3, giving me y equals minus 2/3 x. So I divide the left-hand side by 3, that comes down to y. And then I need to divide each term on the right-hand side by 3 as well. Minus 2/3x plus 6 divided by 3 is 2. So by putting that in that form, I now realize that m is my slope there, minus 2/3. That's the value in front of my x. And my y-intercept is the value after the x, and that is 2. So it says find the slope and y-intercept of the line. We've just done that. The slope is minus 2/3, b is 2. Some of you will remember that there's actually a shortcut for that. And when we have the standard form of an equation, ax plus by plus c equals 0, the slope is equal to negative a over b, and the y-intercept is equal to negative c over b. If I check that, negative a, the a is 2, over b, b is 3. We get slope is minus 2/3, which is the same thing. And the y-intercept is negative c. C is negative 6, so I'm going to say this is negative c. C is negative 6 divided by b, which is 3. And of course, a negative times a negative is simply a positive, so that becomes 6/3, and 6 divided by 3 is 2. So if you remember, and we derived this in grade 9, when we have a standard form of the equation, we can say that the slope is negative a over b, and b is negative c over b, where we're talking about a, b, and c being constants. Both formats would be perfectly acceptable. Okay. What about if we want to write an equation given our slope and our point? Okay. And it says write the equation of the line in slope y-intercept form. So I have to put it in the form y equals mx plus b. But given that I'm given a slope and a point, I'll just rewrite those. My slope, my slope m is minus 2/3, and my point p is 5, 4. I can use the point slope form, right? So the point slope form of our equation is y minus y1 equals m times x minus x1. Given that I'm given, this is known as the slope point form, and I want to use that because I am giving a slope and I'm given a point. So my point 5, 4, that 5 represents my, I don't know why it gives me my point x1. That's my x1 and my y1. That's what the x1 and y1 is in this equation. So I simply sub in these values now. Y minus y1 is 4. Right? That's my 4 value, is equal to my slope, which is minus 2/3, times x minus x1. X1 is that value of 5 here. So now I try to simplify my equation, leaving me with y minus 4 is equal to, my minus 2/3 gets distributed across the bracket, giving me minus 2/3 x. And then I distribute minus 2/3 times my minus 5. Negative 2 times negative 5 is plus 10 divided by 3. So I'm trying to put this in slope intercept form, so I need to have isolate y by itself. So I've got y subtract 4. I'm going to need to add 4 to both sides. Give me y equals minus 2/3 x plus 10/3 plus 4. And so I added 4 to both sides. And now I need to simplify this further by joining these two fractions. And remember, if I want to add my fractions, I need to have a common denominator. So this is 4. That's the same as just 4 over 1. So I'm going to multiply my 4 over 1 times 3 over 3. And that will give me a common denominator of 3. 3 over 3 is just 1, so I'm not actually altering the value of 4. That gives me minus 2/3 x plus 10 over 3. 4 times 3 is 12. 1 times 3 is 3. So y equals minus 2/3 x plus 10 plus 12. And now that I have a common denominator, I can add those together. 22 over 3. And that is the equation of my line. Y equals m. M was minus 2/3 x plus b. So it turns out that the y-intercept is 22 over 3 for the line that passes through the point 5, 4, that has a slope of, negative 2 over 3. Okay. Third example. What happens if we're given 2 points? So we want the equation in standard form of the line passing through the points A, minus 2, 5, and B, 4, 1. So it's interesting. At the very beginning, right, up in our first note, what are the things we say we need? In order to determine the equation of a line, I need a point on the line, which I've got. Yeah, that's great. But I also need the slope of the line. So what I'm going to do, because in this case, I'm not given the slope. I'm given 2 points. Well, we remember we're able to calculate the slope. So the first thing we do is we calculate our slope. First thing, calculate the slope. The slope of the point AB is my change in y over my change in x, y2 minus y1. So I'm going to say 5 subtract 1. And then minus 2 subtract 4. So 5 minus 1 is just 4. Minus 2 subtract 4 is negative 6. And I'm going to put this in lowest terms, giving me negative 2 over 3. Divide both sides by 2. And I've moved my negative. I don't like having negatives down my denominator, so you can put it up in the numerator or just in front. So my slope in this case is negative 2 over 3. Well, I know I need to have a slope, and the second thing I need to have is a point. Right? Well, I've got 2 points, so choose a point. Doesn't matter which point. Let's just, in this case, choose point 4, 1. Look at your 2 points and find out if one of them looks like it's going to be easier to use. At this point, I would say they're pretty comparable, but I'll go with point B, 4, 1. And so now that I have a point and a slope, I do the same thing as the previous question, right? I use my slope point form of the equation, or point slope form. And so step 3, use my equation. So I get y minus y1 equals m times x minus x1. Y minus y1, that's my point here, y minus 1. Oops. Y minus 1 is equal to my slope, which is minus 2/3. We calculated that over here. And then x minus x1. X1 has my value of 4. Now I'm going to solve this in the same way I solved the previous question. I need to rearrange this. To solve for y. Y minus 1 equals minus 2/3 gets distributed across the bracket, giving me minus 2/3 x. And then I multiply the minus 2/3 times the minus 4. Minus 2 times minus 4 is plus 8 over 3. Isolate y by adding 1 to both sides. So I added 1 on the left to get rid of it, and I need to add 1 on the right. And again, I need to get a common denominator. So y equals minus 2/3 x plus 8 over 3. Multiply 1 by 3 over 3. And 3 over 3 is just 1. Y equals minus 2 thirds x plus 8 plus 1, or 8 plus 3 is 11. 11 over 3. So this is great. I've found y, but I just realized write the equation in standard form. So now that I've calculated y, I need to actually convert it into standard form. So I recognize that standard form, I cannot have fractions as my coefficients. So the first thing I want to do is I'm going to multiply everything through by 3. So I'm going to multiply 3 times y. I'm going to multiply the right-hand side by 3 as well. So that just gives me 3y. Minus 2 times 3 divided by 3. My 3's divide out. And I'm just left with minus 2x. 11 over 3 times 3. Again, my 3's divide out. And I'm left with plus 11. And now I need to rearrange my equation so everything becomes equal to 0. I know that I can't have a negative value in front of my x. So I could subtract 3y from both sides, but instead I'm going to add 2x to both sides. So add 2x to both sides. On the left-hand side, I have my 3y. And I need to get rid of the 11 from the right-hand side as well, bring it to the left. I do that by subtracting 11 from both sides. And so this is the equation in standard form. So the equation of a line that passes through the points minus 2, 5 and 0.4, comma 1, that the equation of that line is 2x plus 3y minus 11. Remember, when you're doing work and if you're ever wondering if you want to check your work, you can always hop into Desmos. So I'm just going to hop into Desmos to show that this is indeed true. So if I go to Desmos, graphing, so the equation 2x plus 3 minus 2x plus 3y minus 11 equals 0. That's the equation. And I can check, does it pass through the point minus 2, 5, minus 2, 5? So it looks like it. If I go and I hold that point, minus 2, 5. And the other one was 4, 1. Certainly looks like it. Yeah, 4, 1 was there. 4, 1. So that's just, if you're ever wondering about if you've made a mistake somewhere, you can always do a quick check on Desmos, just like that. It took me 1 minute. All right, so now we're going to take a look at our special equations of the line. All right, so again, this is review from what we've done in the past. The special lines are horizontal lines and vertical lines. So the equation of a horizontal line passing through minus 1, 2, that's my point. What's the equation? Well, if I think about other points on that line, this would be 1, 2, right? That would be 1, 2. And this would be 3, 2. Notice that in every case, that's 1, 2, 2. The y always has a value of 2. So if I can't remember this, I do a quick sketch, I throw some points on, and I recognize that this is a line where every point has the same y coordinate, right? And what is the value of that y coordinate? Y is equal to 2. In standard form, I need to have everything on the left-hand side. So then I subtract 2 from both sides. It becomes y minus 2 is equal to 0. And recognize in this particular case, a in front of x must be 0. B has a value of 1. C has a value of minus 2. That would be the form, the coefficients in standard form. For a vertical line, same sort of idea, 3, 1, 1, 2, 3, 1. This would be, that point there would be 3 minus 1. 1, 2, that would be 3 3. But in every case, the x value is staying the same. So the equation of a vertical line passing through B, 3, 1. This is a line where every point has the same x coordinate, and that x value is x equals 3. So again, to solve that in standard form, we subtract 3 from both sides, giving me x minus 3 equals 0. That's in standard form. And just to recognize what that means is that in this particular case, the a value is 1, our b value is 0 because there are no y's, and then our c value is a value of minus 3. So in general, for the equation of a line passing through the point AB, the equation is going to be for the horizontal line, the y value stays the same, so we get y is equal to that value there, y equals b. And for the vertical equation, it's going to be x is equal to whatever the x value is, which in this case is a. All right, so that's just a review of what we looked at last year in grade 9. And so it may seem pretty simple. Doing the homework to reinforce the concepts is going to really help you as we progress, because we're going to be applying these concepts into more difficult areas. Okay, if you've got questions, please come and see me.